Okay, here's a very typical thing that happens every day. You have friends born on the same day. This isn't a contrived mathematical question just for the sake of solving something. Not at all, because they have people, one girl is 5 years younger than Clara, and then Mike is 2 years younger than Clara, and Thomas is 3 years older than Clara, and the product of their ages was 61,136 greater than the sum of their ages. Because who does that, right? Instead of asking someone their birthday, they give up this crazy thing. Well, what this is a contrived question mainly to see if you're able to take information and put it into an equation, which is a useful thing, even if the question itself isn't that useful.
Were they all born at the same time?
They were all born on March 11th, but the time isn't exactly it. But apparently on March 11th, 2011, they've all said they're the next age older. Okay, so what we notice first of all is they compare everything to Clara. So we're going to make Clara X. Because then we can say, well, Clara's age is X. Leslie's age is X minus 5. Mike's age is X minus 2. And Thomas's age is X plus 3. You would think if they were smart enough to calculate that the product of their ages was 61,136 greater than the sum of their ages, they would be smart enough to ask each other how old they are. Okay? How old was Clara and each friend on that day? So, again, the useful thing is this part. The useful thing is this part. How do we write that into an equation? Okay? The product of their ages. Well, product means multiplying them all together. Okay? X times X minus 5 times X minus 2 times X plus 3 is 61,136 greater than the sum. I'm just going to over here write out the sum quickly. Notice that there's some like terms. X plus X plus X plus X would be 4X. Adding up these numbers will give me minus 4. That'll be the sum. So right now, this is the product right here. If I write 4X minus 4, this will be the sum. We have to decide where are we going to put the 61,136 in order to make this equation equal. Should I add 61,136 to the right side, or should I add it to the left side? Got to add it to the right, because the product is bigger. So in order for these to be equal, now I've created an equation. This is definitely a calculator question. What gives it away? The 61,136. You could, if you wanted to, multiply this out with 4 terms and then combine all your like terms to one side and solve it. I'm going to suggest no. Okay? The way that your textbook goes about solving this is they move everything over to make it equal to 0 and then try to find an x-intercept. I find it's actually even easier if we type the left side of your equation into y1 and your right side of your equation into y2. Then we just have to find out where those two graphs cross. So we'll go to our calculator. We're going to type in x times x minus 5 times x minus, x minus 2. What was the last one? And then x plus 3. And in the other one, we had 4x minus 4, 4x minus 4, plus 61136. Now, I could put the minus 4 and the 61,136 together because they are like terms, but your calculator will do that for you as well. So I may as well type it exactly as I see it so I don't make any mental math errors. Now, unfortunately, when we first graph this, based on the graph that we had to start with, it might not show any intersections. And it doesn't. Okay? A couple of things that we can do to help us. For these huge number graphs, what I'll often start off with is my zoom button, and then I'm going to go and try zoom fit first and see if that fits it nicely onto my graph or not. What I'm looking for is where my graphs intersect. It looks like I've got a little bit, depending on your graphing calculator, your zoom fit might look a little bit different because it might decide something fits better or worse. It looks like it's going to cross somewhere to the right of this and somewhere higher. So I'm going to go to the window that they set me at, and I'm going to go to my Y max and go larger than this. So it's at 61,000. I'm going to go to 70,000. And I'm going to go farther for my X max. I went to 15. I'm going to go to 25. Remember that X is the age of Clara. So there at least we know she's probably not over 200 years old. So it can give us an idea. We're going to say up to 25 years of age right now. So we're going to look at our new graph and see what happens. There's our first equation with the products. And there's our second equation with our line. Now they intersect, so we can go second, calculate. Number 5, where is that intersection? Enter, enter, enter. And we find out x equals 17. So we can solve and write out everybody's ages as a result. She's 17, 12, 15, and 20. So this one is really testing. Do you know how to use your graphing calculator and manipulate the window and solve things that way? Some people like to move this over because then you're finding a 0 and there's less of the window you need to find because you know it has to cross the x-axis somewhere. So that's not bad. Would you like to see how that looks as a second option? Okay. As a second option, that would mean I'm going to rewrite all of this, but I'm going to subtract the 4x minus 4 and subtract the 6136 and make it equal to 0. Because that would move everything to one side. So I'm going to go back to my graphing calculator. I'm going to clear out the second equation, and on my first equation, I'm going to subtract bracket 4x minus 4 bracket and subtract the 61,136. And I'm going to hit graph. And now I'm trying to find the x-intercept. So second, calculate the 0, number 2. You need to go to the left of it. I think 10 looks like it's to the left of it. And my graph went up to 25. So I'm going to say 22 looks like to the right of it. Push enter. And it finds the x-intercept to be 17, which is the same answer. So you have those two options. The other thing is with your calculator, if you ever see this e to the minus 8, that's scientific notation. It means decimal 0.000000178 or whatever number is there, which is really, really close to 0. Your calculator has decided it got close enough and stopped working. We know that the answer is perfectly at 0, but it's just the ability to recognize when your calculator has things like e to the minus 8, that might be equal to 0. Questions you can do to practice this one are 7 and 8. So tomorrow we'll have our quiz.